Okay, a pop fly. Okay, for people that don't know what baseball is, pop fly is a ball. It's hit straight up and goes straight down. It's an easy out. Okay, it's airborne for 8.42 seconds and it's caught at the bat level. Okay, same bat level, same bat time, right? And we're going to ignore air friction, right? It's like, yeah, maybe. Okay, so what time did it spend going up? Well, that's just going to be half the time, right? So 8.42 divided by 2 is 4.21 seconds, right? I'm so paranoid. Did I do that right? Yeah, I did. Okay, what was its initial, what was its final velocity? What maximum height? I think we can do these guys in one suvat. So let's do those. Okay, that'll be the first thing, right? So SUVAT, and we're going from the ground to the top. Okay? We're not going to do all the way back down again. So our displacement is, we don't know. Initial velocity is, we don't know. Final velocity is 0. Acceleration is negative 9.81 meters per second squared, and the time is 4.21 seconds. Okay? So to find the initial velocity, I'm going to use V is U plus AT. And so the initial velocity is, basically it's just 4.21 times 9.81, right? So 41.3001. Okay. What was its initial velocity? So that's that answer, right? By final velocity, I don't think they mean final velocity at the top. I think they mean the final velocity upon impact, right? That's the final velocity they're talking about. We could re-suvat this whole thing from the top to the bottom, but we can also just use symmetry and realize that if it starts at plus 41.3, it'll hit the ground at negative 41.3. Because if it hits slower, that means it lost energy to air friction, and we're ignoring air friction. If it hits faster, then it got energy from like the void or something like that, right? So that's what we're doing, right? So when it says final velocity, they mean to hit the ground, and so that would be the final velocity right there. And then this is our initial. Okay, now back to this suvat where we're going from here to here. Now we can figure out our displacement as well. And we don't really have a formula for that, right? So we have to use this value here, and then I'm going to use V squared is U squared plus 2AS. So 0 squared is 41.3001 squared plus 2 times negative 9.8. I don't know what that mark is there. Nobody knows. Okay. So I'm going to square this, divided by 2, divided by 9.81. 86.94. So 86.9 meters, right? I'll say 9,367. Okay, so now we've answered this question, right? That this is plus or minus 41.3. This one is 86.9 meters high, right? And now they're asking us for the what's happening at an elevation of 60 meters, right? So we'll use this 41.3. I'm going to erase, so you might want to pause. Okay, so now let's answer this question, right? From the previous work, we've gotten this answer here. So let's go SUVAT. Our initial velocity is 41.3001. Final velocity is what we want to find. Acceleration is negative 9.81. Time, we can't do anything with the time. We don't know it's half the time because it's 60 meters, right? We know that this thing goes up and down, goes fully, 86.9 meters. And we're asking about at 60 meters, right? At 60 meters, what's the velocity, right? And so the displacement is positive 60 meters. And then we can do this, V squared plus 2AS right? So our final velocity, the absolute value of our final velocity is the square root of 41 point squared plus 2 times 60, right? And that's positive 60. So okay, squared, 41.3001 squared plus 2 times negative 9.81 times 60. And then I got to square root that. 22.989. So its velocity is equal to positive or negative 22.989. Right, well, you know, sig figs, we have 3 sig figs, so we have to round it to here. Clearly we would round that up, so it's 23.0 plus or minus. And of course the plus is here. On the way up, it's plus 23, and on the way down, it's negative 23. So why are there 2 answers? It passes 60 meters going up, and it passes 60 meters going down. Going up, it's positive 23. Going down, it's negative, okay? All right, I'm going to erase and answer the final question here. Okay, so what's the ball's position and displacement at 5.05 seconds, right? Well, here it is, right? Here's the ground. It goes up, it goes down. Okay, it actually reaches the top at 4.21 seconds, that being half of this, right? Okay. So at 5.05 seconds, it's going to be on the way down. It won't be as high. The highest point here is 86.9 meters, and so it won't be that high, and it will have a negative velocity. Okay? So let's figure this out. Going up, going down. 83. Oh, we don't have the answer to the velocity. Well, we'll figure it out, right? Okay, so let's see about this, right? Our initial velocity is just this guy here, right? 40. And that's actually 41.3001 meters per second. Okay? Our final is what we're trying to figure out. The acceleration is negative 9.81. Our time is 5.05 seconds, and that's meters per second squared, right? And then for v, to find v, I'm going to use v as u plus at, right? So it's 41.3001 plus negative 9.81 times 5.05. That's what the formula is for, right? Okay, 41.3001 minus 9.81 times 5.05. And I get negative 8.24. So indeed it's going down, and in fact it's been going down for nearly a whole second, so it's gained nearly 9.81 meters per second of speed downward, okay? So I guess with 3 sig figs we'd have to say negative 8.24 meters per second, okay? And then to find the displacement, we're going to use this. S is ut plus 1/2 at squared, right? So it's going to be S is equal to 41.3001 times 5.05, okay, plus 1/2 negative 9.81 times 5.05 squared, right? So 41.3001 squared, oops, not squared, times 5.05 minus 0.5 times 9.81 times 5.05 squared. And I get 83.5 meters, 83.47 or something like that, right? So that equals right, so it's 86.9. It's hasn't gone very far. It's at 83.5 meters, right? and it's moving downward with a velocity of negative 8.24 meters per second. All right.